Comenius, Stones, Minerals, Metals, Praefatio, Proemion. As adumbrated in the Orbis Pictus topic Terrae Fetus, What the Earth Bears, at the end of Comenius, The Elements, Part 4, Earth, Comenius descends from creation, the eternal firmament and the four fundamental elements, to the earthly world of becoming, stones and metals, plants, animals, and man. For those who are interested, we offer in this Praefatio some background on one, Comenian taxonomy, the ordering of the topics in the Janua and Orbis Pictus and the great chain of being, and two, the state of mineralogy in Comenius's day. As a reminder, the Janua and the Orbis Pictus consist of 100 topics hierarchically arranged, descending from the apex, the creator and the creation, Deus creavit omnia ex nihilo, hote os hapanta ex udenos ecdicen, to the firmament, and then to the classical four elements from which all material things are composed, fire, water, air, and earth. Now Comenius descends further to the world of becoming, of birth and death on earth. Comenius presents these topics in reverse or ascending order: stones and metals, plants, animals, and man, a ranking that is essentially the heritage of Aristotle's natural history. But this evident taxonomy of Comenius will also remind some of Linnaeus, that is, the taxonomy of the famous botanist Carl Linnaeus, who divided the Creator's bountiful earthly fruits, Comenius's Terrae Fetus, into three kingdoms: the regnum lapideum, the regnum vegetabile, and the regnum animale. Linnaeus was almost a century after Comenius, coincidentally the first edition of the Orbis Pictus and the famous 10th edition of Linnaeus's Systema Naturae were published exactly 100 years apart. But though Linnaeus was a century later, educated Westerners still then conceived of the universe, as they had from late antiquity through the Middle Ages, in terms of an ontological scale, starting with God and going down to the lowest inanimate objects. This hierarchical arrangement was what Sir Arthur O. Lovejoy called the Great Chain of Being in his classic 1936 study of the same name. We will return to Linnaeus and especially his system of Latin binomial nomenclature when we get to plants and animals. Or you may return to Linnaeus when you begin your next game of 20 questions with the question animal, vegetable, or mineral. The great chain of being is an idea with roots in Plato and Aristotle. It was fully organized into a coherent general scheme by Plotinus and the Neoplatonists, and was further developed and debated by medieval scholastics and Renaissance thinkers. It is variously depicted as a linked chain, a ladder. In fact, going back to Aristotle, the chain of being is sometimes called the Scala Naturae, or a stairway. And here's a depiction from the century before Comenius. It's not the prettiest piece of art you'll ever see, but it probably represents fairly well how Comenius will have conceived the universe. Comenius was 24 years old when Shakespeare died in 1616. E.M. W. Tilliard's The Elizabethan World Picture, which is required reading in many college Shakespeare classes, draws heavily on Lovejoy in this idea of the great chain of being. For example, Hamlet's famous speech, "What a piece of work is a man, how like an angel in apprehension, how like a god, the beauty of the world, the paragon of animals," while often taken as an exemplar of Renaissance humanism as opposed to the asceticisms of medieval misanthropy, is actually in the purest medieval tradition, representing man in his prelapsarian state and hierarchically situated between the angels and the beasts. Associated with the idea of the great chain of being is the idea that the chain is and must be unbroken, what Lovejoy calls the principle of continuity. This idea is expressed, for example, in the famous poem An Essay on Man by Linnaeus's contemporary Alexander Pope, published in 1734. Vast chain of being, which from God began, nature's ethereal, human, angel, man, beast, bird, fish, insect, what no eye can see, no glass can reach, from infinite to thee, from thee to nothing. On superior powers were we to press, inferior might on ours, or in the full creation leave a void where one step broken, the great scales destroyed. From nature's chain, whatever link you strike, 10th or 10,000th, breaks the chain alike. There is another associated idea, that all of creation thus ordered is necessary, the principle of sufficient reason, and that it therefore must represent the best of all worlds, even with its apparent evils and imperfections. In this idea lurks an optimism. You can feel it in Comenius, despite the fact that he lived most of his adult life as a religious refugee during the savagery of the 30 Years' War, an optimism that Voltaire, a few years after Pope's poem, lampooned in his brilliant satire published in 1759, Candide, ou l'optimisme, an optimism that many of us in the post-Darwinian world find naive. That's a little bit about the great chain of being, to give some context to the particular way Comenius chose to order the 100 topics of the Janua in the Orbis Pictus. Since we're about to study rocks, minerals, and metals, let's move on now to the state of mineralogy in Comenius's day. To Comenius, the Beginnings, Part 3 Constellations, we attached a preface to explain the transition in Comenius's day from a geocentric to a heliocentric view of the universe. The science of mineralogy was in its infancy in Comenius's day, and before we learn the vocabulary of stones, minerals, and metals, it will be useful to put this science in historical context. Comenius concluded the Terrae Fetus in the Orbis Pictus with the sentence Sub terra nascuntur metalla lapides mineralia, just as he had written in the previous sentence, in silvis nascuntur fungi fraga myrtili. Nascuntur, interesting choice of verb. Where do rocks, stones, minerals, metals come from? Did Comenius really believe they grow in the earth? Well, yes, rocks do grow in the ground, according to the ancient school of philosophers known as the Peripatetics, whose views on natural science largely prevailed throughout the Middle Ages and early Renaissance. Specifically, Aristotle and the Peripatetics speculated that rocks and minerals congealed as a result of the properties such as heat and cold and the interactions of the four elements. So, for example, a brief extant treatise of Theophrastus called Periliton on stones begins, of the substances formed in the ground, ton intege syn istamenon, some are made of water and some of earth. The metals obtained by mining, such as silver, gold, and so on, come from water. From the element earth come stones, including the more precious kinds. He discusses some particular powers of certain stones, for example, the power of attraction, and remarks, but the greatest and most wonderful power, if this is true, is that of stones which give birth to young. Unfortunately, Theophrastus doesn't give an example. Earl R. Cayley, in his translation and commentary on this treatise, hypothesizes that this idea seems to be the result of observing certain kinds of geode-like concretions that consist of an outer shell within which is contained a clayey, sandy, or stony nucleus. The ancients apparently believed that such stones were pregnant, and that the mineral matter on the inside was in the process of being generated. Other ancient authors give the name eagle stone, aitites, to these concretions, and we will encounter the aitites as a stone in Comenius's De Lapidibus. And we will also see that the ancients believed certain stones to have male and female counterparts. Skipping past the medieval astrologers who contributed the idea that the immediate cause of the metals were the planets, and past the medieval alchemists. By the way, not all alchemists were quacks. Robert Boyle and Isaac Newton, for example, were avid alchemists. And skipping ahead to what historians call the early modern period of Western history, we meet the man who has been called the father of mineralogy and the forefather of geology, Georgius Agricola. Agricola lived about a century before Comenius, and we may consider Agricola, especially perhaps because he and Comenius had similar origins in Central Europe, as representative of the science of mineralogy as Comenius understood it. Agricola was a German whose real name was George Bauer. Bauer means farmer in German, as does Agricola in Latin. Agricola was a man of immense book learning, but of an active and practical bent. As a young man, he became the town physician in Joachimsthal, a city in Bohemia on the slopes of Erzgebirge, the Ore Mountains, the then dominant metal mining district in Central Europe. Agricola developed an expertise in mining and is best remembered for his posthumously published work, a handbook on mining and metallurgy called De Re Metallica. But he was also the author of highly influential scientific theories in works such as De Ortu et Causis Subterraneorum and De Natura Fossilium, the epical first systematic mineralogy. Fossilium here means of things dug up from the earth. The age of atomic theory eventually rendered his theories obsolete, but of Agricola's contributions to mineralogy, geology, metallurgy, and mining, Herbert Hoover says, their clarity is as crystal to mud in comparison with those of his predecessors and of most of his successors for over 200 years. And Hoover adds that Agricola was the first to found any of the natural sciences upon research and observation as opposed to previous fruitless speculation. Yes, those quotes are from Herbert Hoover, the future 31st President of the United States, who along with his wife Lou Hoover published in 1912 a first-rate translation and commentary on Agricola's De Re Metallica. Agricola had chosen the then universal language of Latin for his scientific publications, as did Linnaeus 2 centuries later. Their new sciences required new terminology, and they both had to invent new Latin words. In Agricola's case, Hoover estimates several hundred, as well as use older Latin words in new technically specific ways. So where did Agricola think stones and minerals came from? Of his theory, Hoover says that, first of all, Agricola had utter contempt for the biblical view, though, by the way, Agricola was a devout Catholic, as well as for the astrologers and alchemists. From the Peripatetics, he accepted absolutely the formative role of the four elements and their binary properties, as well as the peripatetic theory that every substance had a material cause operated upon by an efficient force. But beyond this he did not go, Hoover says, and rather developed a theory based on his own observations and practical experience. That theory, which Hoover goes on to explain clearly, is too complicated to go into here. I will just note that a central role in it is played by a mineral classification Agricola and his contemporaries called solidified or congealed juices, succi concreti, which are in part solubles like salt and vitriol and alum. We will see the succi concreti in Comenius's metals topic. As we said, the development of the atomic theory in the early 19th century rendered Agricola's scientific theories obsolete. Today, thanks to telescopes like the Hubble, to spectroscopy, and to the collection of geological samples from the Moon, Mars, comets, and eventually beyond, our knowledge of planet formation and rock and mineral origins is growing, well, let's say, astronomically. When you read Comenius's topics on stones and metals for the first time, you will sometimes be surprised by what he classifies as a stone or as a metal. Today, of course, we have different criteria and means for defining what we mean by and for distinguishing rocks from ores, from minerals from metals. For one thing, though the first optical microscope seems to have been invented around the time of Comenius's birth, it did not impact the science of mineralogy for many years to come. Comenius probably followed something close to the classification scheme of Agricola shown on the slide here. Among fossilia, things dug up, Agricola distinguished pure and compounded forms of four things: earths, such as clays, he used the term terrae for earths, the succi concreti, stones and metals. Agricola notes that many of his contemporary authors subdivide the category stones into stones, gems, marble, and rocks. We'll see all of these in Comenius. We also show on this slide Linnaeus's mineral system, though it had a very brief shelf life compared to his botanical and zoological systems. Linnaeus believed minerals were created when various types of soil united with certain salts, the soils acting as the female and the salts as the male. And when we get to plants, we'll see why Linnaeus was sometimes called a botanical pornographer. Finally, to round out our historical perspective, we show the two dominant modern classification schemes for minerals, the Dana system and Nickel-Strunz. As we said, things changed with the atomic theory. The Dana system is a chemical-based classification whose first version goes back to the mid-19th century and the American mineralogist James Dwight Dana. The Dana system has been updated multiple times and is still in use, but is being superseded by Nickel-Strunz, which classifies minerals based on both their chemical composition and their chemical or crystal structure. This system began mid-20th century with the German mineralogist Carl Hugo Strunz and was refined by the Canadian mineralogist Ernest Henry Nickel.